For the self-coders among you, I have here a blank notebook and the project brief for project number 4, merging, cleaning and transforming data. And we are starting with the clean dataset movies clean.csv that we prepared in the previous project. And the plan is now to add the additional features cast and crew that are stored in the second file. So it's the credits.csv file. And first of all, as always, you should load and inspect the two datasets. And you should also be able to identify stringified or nested JSON columns in the credits dataset. And before we can join or merge the datasets, first of all, you should drop the duplicates in the credits dataset as well. And then it's time to merge or join both datasets. And essentially, you should add the columns or the features cast and crew to the movies clean dataset. And you will find those two features in the credits dataset. And once you have merged or joined the two datasets, then we have to clean and transform the cast and the crew column. So this is pretty similar to the previous project. And first of all, you have to evaluate the actual Python expressions in the stringified column cast and remove the quotes. And then you have to determine the cast size and add the additional column cast size, so the number of actors per movie. And then you should also extract all actor names from the cast column and override cast. So if a movie has more than one actor, then you should separate the names by a pipe. And for example, the movie Toy Story should have the following value in the final cast column. So it should be the string Tom Hanks pipe, Tim Allen pipe, and so on. So we have quite a few actors here. And also here you should finally inspect cast with value counts. And maybe you can see anything strange and take reasonable measures or actions. And the same you should also do for the crew column. So you should first of all evaluate the actual Python expression and remove the quotes, and then determine the crew size and add the additional column crew size. And finally, you should extract the director name from the column crew and create the additional column director. And also here we have an example. So for Toy Story, the director is John Lasseter. Last but not least, you should drop the crew column and save the final dataset in a new CSV file. And also here, as always, you can find some hints here below. So have fun with this project, and looking forward to seeing you in the videos. Bye. Alright, we have our cleaned movies dataset in place, movies clean.csv. And we import and save the dataset in the variable df, and we make sure that the release date is actually a datetime column. So we should be already familiar with this data frame and dataset here. And then coming from another data source, we have the dataset credits containing information on the movies cast and crew. And let's also import this dataset and save it in the variable credits. So here we have the cast and the crew and also the movie ID. And this is essentially, or this should be the very same movie IDs as above in our other data frame. So this is actually the column that we can use to merge both data frames later on. But first of all, let's have a look here. And also here we can see that we have kind of a stringified JSON or nested JSON data here in cast and crew. And also this dataset is originally coming from JSON. And let's get some meta information with info. And here we have slightly more rows or more movies than above. But this is actually no surprise, as before here with our movies dataset, we actually removed some rows and some movies. So finally, let's have a look at one element in the cast and the crew column. And also here we are faced with the very same problem as before. We have stringified JSON data, and we have double quotes here inside. So this is actually not a valid JSON format. And also in the crew we have stringified data, and therefore we will also have to do some data cleaning and converting. So, but for the time being, we have finished now the very first inspection and the data import, and see you also in the next lecture. Bye. Before we have seen that we have nested data in the columns cast and crew, and either we can clean this before we merge both data frames or afterwards, and we can do both, but let's decide to do this after having merged the data into one data frame. And the plan is now to add the columns cast and crew to our movies data frame and create two new columns of features. And it's good to have the movie ID in both data frames or data sets. So it should be pretty straightforward to add the cast and crew of, for example, the movie with ID 862 to the corresponding movie or row in the other data frame. And we should be able to do this with a simple left join on the ID column. So we will see this in more detail in the next lecture. But first of all, let's focus on the ID column here in the credits data frame. So the ID column is pretty important, and therefore we should first of all analyze the column. And let's recap that in the other data frame we had to remove some duplicates. And also in the credit data frame, we should make sure that we only have unique values in ID. So let's check this. And also here we have some duplicates, and this doesn't really make sense. And also here we can filter credits for the duplicated rows in terms of ID. And for instance, we have here the first pair of duplicates, so with the very same movie ID, then here the second and so on. And again, with drop duplicates, we should make sure that we only keep one instance, so the first by default, of these pairs in our data frame credits. And finally, let's make a cross-check. So now we shouldn't have any duplicates here, and that's correct. All right, thanks for watching, and see you also in the next lecture. Bye. Welcome back. We are ready for a left join, and you might know this as a VLOOKUP in Excel. So the left data frame df is actually the main data frame, and for each and every row or movie in df, we want to get the cast and the crew from the right data frame credits. But before, it's always helpful to understand what's in the left and what's in the right data frame. And first of all, we can check whether there are any movies in df for which we do not have cast and crew information in the credits data frame. So we check for all movie IDs whether they are not in the credits data frame, so tilde stands for not. And then we filter df for those movies, and let's have a look if we have any movies, and obviously we have no movies here. And that means that we will get the cast and the crew for all movies in our movies dataset. Next, we can make the check the other way around. So we filter those movies where we have cast and crew data, but no information in df. And obviously here we have quite a few movies, in total 741 movies that are in credits, but not in df. And actually I can tell you that these are exactly those movies that we have dropped earlier from the movies dataset for the one or the other reason. So everything is reasonable here. And now we can perform our left join or left merge with the merge method on the left data frame df. And we pass credits as the right data frame to the parameter right. Then we have to define how to merge, and actually we have the choice between inner join, outer join, left join, right join, but here clearly this is a left join. And finally, and that's the most important step, we can define on which columns to join. And actually it's no surprise that you want to join on the movie ID, so we have in the left data frame the column ID, so left on ID, and also in the right data frame the column ID. So let's run the cell and let's overwrite df. And we're actually adding 2 more columns to df, cast and crew. Let's have a look here. So still we have 44,691 rows of movies, so this hasn't changed. But now we have 20 columns, and we can find them here, the 2 additional columns on the right-hand side. So here we have now cast and crew. And we can also have a final look with the info method. So we have 20 columns, and obviously here we have no missing values. But of course, we also have to clean and transform cast and crew. And that's exactly what we are going to do in the next 2 lectures. So thanks for watching, and see you there. Bye. In this video, we are going to clean and flatten the new cast column. And actually, most of the steps are similar to those in case 2, where we cleaned the stringified and nested JSON columns, genre, production companies, and more. And therefore, I will keep it short here. And again, we import the AST module and also NumPy. And let's have a look at the very first element in the cast column. So here we have a stringified JSON data, so to say a stringified list. And we can extract the list here with the dictionaries inside, with literal eval. And actually we apply on each and every element the lambda function here. And before we have to check whether the element is an instance of the string class or not. So let's override the cast column. And let's check the first element. And now this is here JSON data, and we have a list. And each and every element in the list is a dictionary with information on the respective character and the actor name. So in this movie here, it's just the voice. So it's an animation movie, Toy Story. And actually for each and every movie, we can convert the information in the cast column into a separate data frame. So let's pass here the first element for the first movie to pd.dataframe. And here we get a data frame with quite extensive information on the cast of Toy Story 1. So in total we have 30 actors or voices in this case. And we have the cast ID, the character, credit ID, gender, then the actor's ID. And this corresponds to the actor name. And here we have some order. And finally, the profile path of the actor. And actually, we could create such data frame for each and every movie. So in total, we have over 45,000 movies. But for our purposes, we are not interested in all of the information here. So we are only interested in the actor names. And we only want to get the actor names for each and every movie in a string separated by a pipe. But first of all, we are also interested in the cast size, and we can create a new column, cast size, and we can determine the length of the cast list with a lambda function again. And by doing so, we determine the cast size. And let's analyze the column here. So let's have an example. So here for Toy Story, we have a cast size of 13, then for the next movie of 26, and so on. And let's also analyze the new column with the value counts. So the most common cast size is actually 10, then we have 8, 7, and so on. So this seems reasonable. And as I said before, now we want to extract the actor names for each and every movie and actually store them in a string separated by a pipe. And by doing so, we override the cast column. And let's check again here. So here for Toy Story, we have Tom Hanks, Tim Allen, Don Rickles, and so on. And we can also further check with value counts. And obviously here the most frequent value is an empty string. And we should replace this with a missing value. And of course we can do this with replace. And let's check again. This was the cast column, and in the next lecture we will clean and flatten the crew column. So hope to see you there. Bye. In this video we are going to clean and flatten the new crew column, and let's have a look at an example. And also here we have stringified and nested data, and again we apply literally well on each and every string to extract the data, else we have a missing value if it's not a string. And we override the crew column. And let's again check it. So here we have now for each and every movie a list containing dictionaries, and each and every dictionary is actually a crew member. So here in the very first dictionary we have the director John Lasseter. Then in the next dictionary we have the job screenplay, and it's Joss Whedon. And also here we can convert each and every element in the column into a data frame with detailed information on the crew. So for Toy Story we have in total a crew size of 106, and we have the department, the gender, the ID, the job, and the name. So if you like, we could extract around about 45,000 data frames with crew information, so for each and every movie. But for our purposes, we are only interested in two things. So in the crew size and in the director. And first of all, we can get the crew size and create a new column, crew size. And we simply check the length of the crew list for each and every movie. And let's analyze crew size with value counts. So the most frequent crew size is 2, 3, and 1. So that's pretty small productions. And actually we also have a crew size of 0. So this seems to be reasonable. And finally we want to get the director, or extract the director. And again, let's have a look at the data structure. So for each and every movie we have here a list, and in the list we have dictionaries. And in the dictionary there's actually one crew member, and we want to extract this crew member and the name of the crew member, that is the director. So we should actually iterate over the list, and in case we find the job director, then we should take the name, John Lasseter in this case. And for this we need to create a user-defined function that we can apply to each and every element in the crew column. So the user-defined function getDirector. And as I said before, so we iterate over the list and check whether the job is director or not. And if it's director, then we take the name. And finally, if we do not find any director, then we return a missing value. So let's define the user-defined function, and let's apply it on all elements in the crew column. And by doing so, we create the new column director with the director name. So let's check this. So here we have John Lasseter, Joe Johnston, and so on. And finally, let's have a more detailed look with the value counts. And here we have over 700 missing values. Then the most active or most frequent directors, John Ford, and so on. Alright, thanks for watching, and see you in the next lecture. Bye. Alright, let's have a final inspection, and let's have a look at the first two rows or movies. So we have the ID, the title, and many more features. And at the very end we have the cast size, the crew size, and the director. And still we have the column crew with the nested data. And now we can drop this column. And also we could check again the meta information, if everything is reasonable or not. And this is actually the case here. And finally we can save and export our data, for example, to a CSV file, moviescomplete.csv. And finally, after spending a couple of hours on importing, cleaning, and merging the dataset, we are now ready for explanatory data analysis, data presentation, machine learning, and many more things. So thanks for watching, and see you in the next case. Bye.